Okay, class, we're going to go ahead and continue with our math class. But this time what I'm going to do is I'm going to go ahead and I'm going to use 4 different numbers to show you 4 different ways that you can do mental math. The purpose of mental math is for you to be able to somehow do what we're doing on paper now to eventually transfer that to actually doing it in your mind. So what you're doing on paper now, we're trying to transfer it to being able to do it in your mind. Okay, class?
Okay.
All right. So I'm going to have, today, I'm going to actually have Isabel. She's going to hold my camera for me. Okay? And I want you to put it right up here on the board while I go ahead and I explain it. Make sure you're holding it sort of like this. Okay. Thank you so much, sweetie. All right, so here we go. We're going to take a look at our first problem, which is problem number 1 on our reteach sheet. And we're going to actually use the commutative property to change order of factors. So we have 5 times 7 times 20. We do that when we have 3 different factors that we're multiplying together. Okay? So what we're going to do is we're going to ask ourselves, when we're dealing with the multiplication process, when we bring our numbers together, which 2 numbers could we easily multiply together in order to make the rest of our multiplication even easier? As I take a look at this, I know that 5 times 2 is 10. Yeah. And so I'm going to bring my 10 down, and then I'll just drop my 0 next to it, and that gives me 100. Then it makes it really, really easy because the only thing I have left is my 7. And so I'm going to say 7 times 100 equals 700. And so now I'm able to multiply and come up with my total answer. Again, this is using commutative property in order to change the order of factors in order to come up with my final answer, okay? That's number 1. So I'm going to actually label it, and I'm going to say commutative property. Okay? Number 2. The next thing we're going to do is we're going to take a look at 6 times 321. Now, as we've learned in the past, we can take this number right here, and we can multiply each of these numbers, the value of each of these digits. We can multiply the value of each of these digits by this number, add them together, and come up with our final answer. But we can also use what is called the break apart larger factors in order to help us to solve as well. And so that's what we're going to use. So it's literally saying I can go 6 times 300, and then I'll say 6 times 21. Now some of us may look and say, well, I don't know what 6 times 21 is. That might be a little hard, and that's why I said use the other math if you need to. But 6 times 3 is 18. Then I would drop my 2 zeros, and then I would literally say 6 times 21. Now in my head, I can automatically do it because of course I should. I'm your teacher. And it would be 126. However, what I did do in my mind, I said 6 times 1 is 6. And then 6 times 20, because the value of the 2 is 20, is 120. I already know that I have 6 in my ones place, so I'm going to put just my 12 there, and so it's 120. So I kind of skipped a step in this. Then what I'll do is I'll take and I'll add that together, and that will give me a total of 1,926. Do you guys see that?
Yes.
All right. This again is called the break apart method. All right, and again, if you need to do it the old-fashioned way that we've been doing it in the past, you can say 6 times 300, 6 times 20, and then 6 times 1. We basically did that, except the 20 and the 2 and the 1, we kind of brought it together in our mind, okay? Now, let's go ahead and take a look at number 3. Number 3 is 86 times 50. And in this particular case, we're going to use the halving and doubling process in order to be able to come up with the final answer. In here, what we're going to do, instead of breaking this in half, we're going to double that number. Remember, in our other problem, we broke it in half. In this particular case, in order to make math easy, we're going to take this number and we're going to double it. So we're literally saying 86 times 50 equals 86 times 50, or no, not 50, times 100 And you're correct, Dwayne. And so it's 86 times 100 minus 50. Oh, yeah. Okay. All right. Or what we could do is just say, we can just go ahead and just go on and bring it together. So we don't even have to do the minus 50 because we're doubling it. So we're going to say, okay, 86 minus 100 is what? Or times 100, sorry. So 1 times 86, well, we all know it's 86. And then we're going to bring down our 2 zeros, and that is what?
8,600.
8,600. Now, what we have to do is we have to take this now and we have to divide it in what?
2.
Divide it in half or divide it by 2. And so we're literally going to take the 8, and half of 8 is what, everybody? We automatically
Half
know.
of 8 is 4.
Half of 6 is what?
3.
Good job. And then we just bring down our zeros. Now we can check it by saying 43 plus 43 and see if we come up with that answer. But basically, our answer, our final answer, when we say 8 times 50 is what?
400, 300.
What?
4,300.
4,300 is our answer. Guys, you were scaring me. Okay, now this part that we just did is the actual halving and doubling. So, okay, you guys got it so far?
Yeah.
Okay. Last but not least, we're going to take this number right here, number 4. That's kind of interesting because now when we do number 4, we're going to literally say 9 times 399. We're going to use the subtract to break apart the larger factor. And that's where this is really, really super easy, guys. Because what we're going to do is we're going to round this to its place value, so its greatest place value, which would be what? If I take 399, what's the greatest place value? The 9 lets us know that the 3 becomes a?
4.
Thank you. So now we round it to what?
400.
400. Ooh, you guys are scaring me here. So I'm literally going to say that this equals 9 times 400. Okay? So it's like we're taking it and we're just rounding it, and it's like when we estimate to find a product, okay?
Okay.
But we're not done yet because that's not the problem. The problem is we have to find the exact answer, which is 9 times 399. So then what do we have to do?
We have to
Subtract. Who said that?
Ben.
Thank you, Ben. We have to subtract, and we're going to subtract what from 400 to get us back to 399? Say it again.
1.
Yes, so we're going to minus the 1. So we are literally going to set up our problem, and we're going to say 9 times 400 minus 9 times 1 in order to come up with the actual answer. This is the easier way instead of trying to come up with this answer and kind of manipulating our way through the problem. So we're going to say 9 times 4 is?
36. 9 times 4 is 36.
Yes, and then what is 9 times 1 is?
9 times 1 is 9.
9. And so we're going to literally take the 9 from the 3,600, and that'll give us what answer? 3,500 and 90 what?
92.
We're taking 9 away, not 8.
0. 91.
Thank you. Guys, you're scaring me. Okay, so it's 3,591. If you need to set it up and go ahead and borrow all the way through, you can. I would just count back on my number line. You guys have number lines on your name tags, but you can also use your hands and count back 9 spaces until you get to 3,591. Okay? And that's your final answer. And hold on 1 second. So this is what we call subtract to break apart. Yes, somebody had a question.
Oh, I did.
Mm-hmm.
But we don't have to do that subtracting thing. We can just do like how we've been doing it during the week. Or
You
no?
can do how you've been doing it, but this is actually easier. You might want to try it.
How's it?
I'll tell you why it's easier, because now we're taking it and we're just rounding it to its greatest place value, which you already know how to do that. So now we're taking all our skills that we've learned in the past and we're bringing them together. Okay?
I don't get the part where you're like 9 times 400 minus 1.
Oh, because then we round the.
Let me answer that. Okay, so we have to take this and round it first, or we take it up to its greatest. So we're going to ask ourselves, 399 is between what hundreds? 300 and 400, correct?
Yes.
But it's not going to round down to 300, so it's going to round up to what?
4.
It's going to round up to 400. If we round it up to 400, we have added how many to the 399 to get it to 400?
1.
We added 3 to the 1, okay? And so we have to subtract that, we have to take that away. But in order for us to be able to multiply, we're trying to make it easier. So we set the problem up and we say 9 times 4 is 36. We drop that, that's 3,600. That's an estimated number. However, we know that we added only 1 to that 9 times. If we multiply this by 9, then we have to subtract the 1 by 9. Okay? Because we multiplied an extra 1 9 times. So we have to take that 1 away. All right? And so we multiply 9 times 1, and that will give us 9. And then we subtract it, and that gives us our final answer. You understand?
Kinda, not really.
Okay. It's going to take practice, yes.
The number for number 2 and like the numbers for number 4. What about, are we allowed to the way that to put the higher one on top and the lower one on the bottom? Like the the one we,
You're talking about how we did it the other week?
no.
What are you saying?
I believe that,
This one right here?
no.
Which one are you talking about?
It's what I'm saying is, can we do it like, so if you have 300 cut to the on the top of that times 6.
Where are you locating? I don't know which one you're talking
2.
about.
She's talking about 2.
You're talking about this one, right?
Can you
Okay.
Can you do it the way where you stack the numbers?
We just stacked them.
Not that way though.
You're talking about the old way that we just did before. Is that what I asked? That's right. So like we did like this. Are you saying like this, can we do this? You're asking me, can we do that times that times that, and that times that, correct? Okay, I don't understand what your question is. What's your question?
Yes, and I'll show you later.
Huh?
I'll show you what I mean.
Okay, but you're not asking about the old way, okay? I really would like to know what you're asking, and I'd like to put it on a video, so in case you all have that question later, we could, so are you asking about the new way, right?
No.
Okay,
Not like
okay, so we'll talk about it then, okay? Oh, you're talking about I get what you're saying. Are you allowed to just do the regular multiplication?
that.
Yes, you are allowed to do that if that works for you. I get her question now. So her question, can you hold this again for me, Isabel? So her question is, I get what she's asking now. Thank you. Thank you for sticking with me, Monka. Okay, so she's saying, if you have this is your multiplication problem, and if you take it and do it times that, is that okay? Because sometimes we can go ahead and we can do our multiplication problem just like that. 1 second. Thank you. And she's saying, if you know how to do that, can you do that? And my answer is yes. If you don't, I don't want to add that to your plate today. So I'm not going to add confusion. And but if you already know how to do this because you've done it in the past, sure, go ahead. If you don't know how to do this, don't do it. Okay? I want you to do either one of the methods that we went over today or the methods that we went over yesterday, the one that I just erased, okay? But if Monka or someone else knows how to do that, then go ahead and do it. Okay?
Okay.
All right, guys. We're going to continue our math class, but I'm going to go ahead and take us offline.
No.